Alrighty team, so in this video, and I don't know how many it'll take me, but we're going to go through 19b, which talks about latitude and longitude. Please bear with my voice and me trying to talk and breathe, but yeah, we'll do our best to get through this, okay? So 19b focuses on the latitude and longitude, which is all us talking about the globe and the Earth. And it all comes back to this idea that the Earth is a sphere with a radius of 6,400 kilometers. So I am just going to flick over to this website here that I found. We'll see how she goes. Hold on a sec. So if we look at this globe here, because I would show you the globe in class if I was there right now, but we know that the Earth is a sphere and we can't see the center of this sphere on here, but imagine from the very center of the circle out to any edge of the Earth that we take is a radius of 6,400 kilometers. What we can see on here are some features though that I think are important to talk about. So first of all, at the top we've got our North Pole, okay? And then, is it gonna, nope, sorry, I've just gotta, it's very sensitive. At the bottom we've got the South Pole, it's like merged just on through. And there we go, and I can rotate her orientation back to being correct. So if we flip back to the notes for a second, just at this diagram that I've got on the right hand side, at the very top here, this is our North Pole, and down under here we can't see it, but underneath we would have our South Pole. Now, connecting the North and the South Pole are actually these red lines which wrap around the Earth, and all of the red lines are our lines of longitude. So think that they go a long ways around. And all of these blue horizontal lines are our lines of latitude, okay? And we're going to talk about each of them in a bit more detail shortly. But what these lines of longitude and latitude do is they allow us to give coordinates of specific places of the Earth. And so we can say Melbourne, for example, its coordinates are 37.81 south and 144.96 east, which means its latitude is, say, 38 degrees south and its longitude is, say, 145 degrees east, and that gives us a specific point where Melbourne is located on the globe. Now, what all these lines do is create what are called great circles and small circles around the Earth. Now, a great circle, if we think of the word great, we think really big. So it's a section of the circumference of the sphere that involves the diameter or the full distance from one side to the other and going through the center of the sphere. So the equator and the lines of longitude then are all great circles that exist around our globe. So if I go back to here for a second, the equator is this red line here. And this is the circle that wraps around at 0 degrees latitude, and it wraps the whole way around the Earth. And it uses the diameter of that sphere, so it would use the radius of 6,400 kilometers, or double that for our diameter, and uses the center. And so what that's saying is with the equator, if I cut our Earth in half along this red line, hopefully you agree with me, this would split it into our northern hemisphere up here and our southern hemisphere down here. And both of those circles, if I opened them up and looked at them, both of those circles would be the same size, and that would be the largest possible circle that I could create from this sphere. Now, with our lines of longitude that wrap around, so this 2 shows me a longitude line, so all these vertical lines, they also wrap the whole way around the Earth, and they're also a great circle because if I cut the Earth in half on one of them, I would again create 2 hemispheres in a vertical direction, and those circular faces would be the same size, and they would be the largest possible circles that I could cut within that sphere. Small circles, though, do not contain the center of the sphere, and lines of latitude are our small circles. So if we think about this for a second, if I cut, sorry, it's very sensitive. Let me just try and zoom back out again. if I cut our Earth along this equator, we've said we'd get a really big circle being cut. But hopefully you agree with me, if I cut the Earth along this line up here at north 30 degrees, that circle up there is going to be smaller than the circle at the equator. And so that circle up at that line of latitude there, we would call a small circle. So to keep going through these lines of latitude with a bit more detail then, the latitude of a point is actually the elevation or the depression of that point from the equator, because our equator has a latitude of 0 degrees. So over here we can see the bottom hemisphere drawn in, and the north hemisphere has actually become a series of circles. But from 0 degrees north, which is that equator, we've then got 30 degrees north labelled, and we've got this little angle 30 degrees being shown in here. I'm going to come back to that in a moment. Lines or parallels of latitude, they run horizontally and parallel to the equator, and they're equidistant from each other. And the equator is a great circle, okay, but lines of latitude become small circles. And the North Pole has a latitude of 90 degrees, and the South Pole has a latitude of 90 degrees south. So if we cut the Earth along a great circle, so along a line of longitude, we can create this vertical line that joins our North and South Pole together. So if I just draw us another circle here, it's a beautiful circle. I can think about the equator here. This is at 0 degrees, so this is my equator. And if I'm now thinking about the South Pole being down here, this is me moving 90 degrees south, and my North Pole up here is at 90 degrees north, okay? Those lines of longitude then run horizontal, so we can see at this diagram on the left, this is our 30-degree line of latitude, and what it means is if I take my radius from the center out to that 30-degree north line of latitude, this angle that gets created from the equator up to that line of latitude is 30 degrees. Likewise, if I'm looking at somewhere 60 degrees south, it means that we move 60 degrees from the equator down to the line, and so 60 degrees is that angle created there to get us to 60 degrees south, okay? So if we were thinking about Melbourne, for example, Melbourne was at 38 degrees south, and so we would be talking about going from the equator, measuring out 38 degrees this way. Melbourne would exist then on the red circle at 38 degrees south, and if I wanted to draw its line of latitude, that means that this horizontal line through here is the line of latitude that is 38 degrees south. So any other points that are around that small circle will have a latitude of 38 degrees south. The final thing then with longitude is lines of longitude are measured in degrees east or west of the prime meridian, which is also called the Greenwich meridian. And so this gets measured as our 0-degree line of longitude. And our Greenwich meridian, or our prime meridian, is this line here. And it's called that because actually, if I can just drag this up here, it gets measured from Greenwich, which is effectively in London. And so we have then 0 degrees. Now, if we just look along this red line for a sec, you can see over here it's got east 30 degrees labelled and it's got west 30 degrees labelled. So when we now start to think of lines of longitude, they get measured from the prime meridian, and if we're looking towards the globe right now, we know east is this way, and so if I go along here, I get further and further east. So Australia is all in those east something, and we said before that Melbourne was effectively east 145 degrees, until eventually we get to this 180 on the other side. Now, if I wrapped around in the west direction, I would have west 30 degrees, and slowly I get more west as I make my way around the globe and I get to America, and then I get to that 180 degrees line on the opposite side, okay? So what happens is that from this prime meridian, which is this line labelled on here, okay? This way gives me degrees east, and this way gives me degrees west, okay? So again, up here, this is degrees east, and out this way is degrees west. And those lines of longitude actually wrap the whole way around the Earth. So when I had that 0 degrees Greenwich meridian, it would wrap all the way around to be that 180. So if I actually went vertically above the globe, can you see this purple line then becomes that 180 line on the other side? It won't let me flip it the whole way around. But what we can also see then is on here, is if we look at, say, this line of 60 degrees east, it matches up on the other side with 120 degrees west. And so they both add up to 180 degrees, because I know that if I split the globe in half, half of 360 is 180 degrees there. So those show us our lines of longitude. I'm going to stop the notes here before I go on to do the next lot of examples. So that will be in the next video for us.